It's fun to see some familiar faces out there. Thanks everybody for being on. Um, and thank you to Sustainable Solano and Nicole. I really, really enjoy all the events that I've done with your organization, and just so impressed by how much you have collectively done over the last several years with the food forests, and to go up a couple weeks ago and see the food forest and do our little video tour was really, really fun. And I started my permaculture journey in 2003. I think I had just had a baby. Well, I think he was 2 maybe then, and now he'll be 19 in July. So yeah, time is slipping away, but I had this sort of pause with my little baby, and I was home, and I had always been interested in gardening, and I'd always been interested in water, and I heard about permaculture, but I didn't really know that much about it. And I finally took a course, and it was in Alameda at the Alameda Point Collaborative, something like that. It was focused on urban permaculture, and it had guests, like all guests. So I had Penny Livingston and Brock Dolman and Larry Santoyo and Toby Hemingway and John Valenzuela, and like every big name you can think of. So that was a really great way for me to get started. And from there, my whole career has really unfolded. Just the doors have opened. And Penny Livingston has been my mentor for the last 17 years. And something that she said before we even knew each other, I just heard her speaking. She said, if you commit your life to this path, the doors will open. Like, this is what the planet is needing for us to become engaged with. And so all you really have to do is just let your heart say yes, and dive in with whatever little piece interests you the most, the first. And so for me, it was water, and particularly gray water was like the coolest thing I ever heard of, right? Like, oh, we already paid for that water. It's already been used once. Like, let's use it again. That's a whole nother webinar. But yeah, and then as I've undergone this, decade and a half of exploration and discovered all of these other teachers from around the world, and the kind of rediscovering of how we care for the planet, the refining of our understanding of what is going wrong, and the realization that it is within our capacity to make meaningful change and begin healing and regenerating. That's just blown my mind. And so that's what gets me up every morning, and that's what kind of gets me through all the hard times and the news. And honestly, I have found myself in an excellent position right now through the pandemic, the coronavirus, the shelter in place. I have lots of work helping people grow food, take care of their landscapes, really be agents of healing and change. And so it's been tremendously rewarding, and I'm so happy to be here today. So thank you so much. So I do have some neighbors doing some blowing or some lawn work. So let me know if it gets too loud, and I'll put the earbuds in, and then I'll have the microphone, and that should be a little bit clearer. So, alrighty, I guess I'm gonna get started with my slides. So these are from my flip charts, and you can see they're sort of like, sometimes I had to do the text over the flip charts, but yeah, they still have that homey feel. So I hope you'll enjoy them. Let's see. Okay. So my business name here in Santa Cruz is Rehydrate the Earth, and plant water, keep trees, grow rain. That is my clever little word game, because what, plant water, keep trees, grow rain? Like, did you get the words mixed up, Lydia? What's going on? But no, over the course of the next hour and a half, I think you'll come to understand why planting water is really the first step. And all of the work that I've done with water has been merging with all of the new information about climate change, and really coming into this beautiful new understanding of what's going on our planet. And so, yeah, for me to name my business Rehydrate the Earth just made so much sense. And then as I speak and I share with you some of my other mentors and the people who've inspired me, there's another gal who's working with this organization called Rehydrate California, and I didn't even know that there was such an organization. I was like, okay, well, we're all on the same track. That's excellent. But what is the point here? Rehydrate the Earth. Why? How? What does that really mean? Well, so rehydrating the Earth means facilitating water's capacity to get back into our landscapes. That what's been happening over the last couple of 100 to 10,000 years is that our land management practices have changed the surface so that water, when it falls, it's not as likely to soak in. It's more gathering, pooling, running off, flooding out in streams, storm drains, roads, causing property damage, causing massive ecological damage. And why is that happening? How can we recognize that that has happened on our lands, the places that we do get to steward and care for, and how can we reverse that process? And there's really this massive triumvirate of water, soil, and plants that are working together to maintain the stability of our planet, to maintain the climate that we've evolved in, that we all keep expecting to stay the same. And so to increase surface permeability and water infiltration and underground storage allows all of these other processes to unfold. And one of the main reasons why we need more water in the landscape is so that we can support the vegetative growth that is then pumping water vapor constantly in order to stabilize the climate on the planet. So as we have come through and cleared forests to burn them, first it was for the steam engine in the 1700s, like, oh yeah, mechanical power is so great, like we don't need slaves anymore. Awesome. But okay, let's cut down a bunch of trees and burn them. Trees are photosynthesizing and drawing carbon out of the atmosphere while they're photosynthesizing and reaching their roots down deep in the earth and holding the soil and allowing the water to infiltrate, and cutting down all of them. More on that to come. Okay, so increase the soil capacity to hold water and carbon via vegetation, right? Okay, so what happens when plants are growing and they're taking carbon in from the atmosphere? So just a quick little photosynthesis overview here. So plant leaves have pores in them. Imagine this is a leaf. The underside of the leaf has these little holes called stomata. And the stomata are like little mouths. And so when the plant is in the sunshine and it's photosynthesizing, it opens its little stomata and it's able to take in carbon dioxide. And it takes in carbon dioxide and it uses the energy from the sun and the carbon dioxide and water that it draws up from its roots. And it converts that into carbon chains, like its own flesh and these sugary exudates and microbe food and all of this stuff. And whoa, oxygen. Okay, so then it exhales oxygen out of the stomata while it's making all of these carbon compounds with the carbon that it's taking out of the atmosphere. So this is a phenomenal, amazing process that is the reason why we are all here. So plants, the proliferation of plants in our early evolution and the subsequent production of oxygen created this massive change in the life on the planet. And then oxygen breathing animals were able to evolve. And so a little fact that people often aren't clear on is that actually trees at night, plants at night, they need to consume oxygen and they give off carbon dioxide just like animals do. But during the day, they far and away exceed the amount of oxygen they used at night in the amount of oxygen they produce during the day. But I always thought that was kind of cool. Like, oh yeah, they make oxygen in the presence of sunlight when they can photosynthesize. But they engage in cellular respiration just like us, consuming oxygen in the dark. Okay, what else do plants do? All right, so their actual bodies. You know what, there's so many, okay, I had a little bit of caffeine this morning and I have so much that I want to share. So, and I know that some redundancy is really helpful, but I want to try to be systematic in my presentation of the information here. So I'm going to go deep into trees and then maybe come back to some of the slides in a little bit, if that's okay with everybody. So plants, they're increasing the soil capacity to hold water and carbon. How? Okay, they're actually, with their roots, they're sending, live tissue down into the ground. And then some of those roots stay alive, some of them slough off. And when they slough off and they're no longer active, they're like little microscopic seams of compost that other organisms can utilize. They're also like, creating their own bodies, all this biomass, and then they're dropping leaves, and then they're providing habitat for all these creatures that are then pooping and then dropping their own bodies. And so there's this like soil creation that's happening underneath the tree just by virtue of the tree living its life, right? And then there's this cooling and protecting that happens, right? So let's look at another slide where, yeah, here we go. All right, so how a tree interacts with rain. And let's see, I need to move my little picture box here so I can see okay, there we go. So here, this is a drawing that I usually show on a flip chart, but it's from Bill Mollison's designer's manual. So it's from the Permaculture Book of Books. Kind of a tough one to start with. It's very dense. It's very Bill Mollison. He has his own kind of flavor and style, but a really amazing resource. And I'll share lots of resources as we go here. So, oh, I forgot to start my timer, but all right. So here we have our tree, and you can see as rain falls, the leaves actually get hit by those raindrops and they absorb that kinetic energy. When rain falls on bare ground, those raindrops are moving very fast. They've just fallen a long, long way. And so that falling on the bare ground actually like pulverizes the soil structure, breaks it apart, turns it into little tiny particles and medium-sized particles and bigger particles, as opposed to a multi-particle conglomerate. And these multi-particle conglomerates are actually formed by the secretions from the soil microorganisms. So we need the soil microorganisms to create this soil structure, and the soil structure then allows there to be different size pore spaces, which allows water to soak down into the earth. So when we have rain falling on bare ground, we get a very negative effect of blasting apart the soil structure, breaking it down into its constituent particle sizes, which then allows the smallest ones to kind of filter down past the bigger ones and create like an impermeable layer of small particles to kind of seal up the pore spaces. And when the water lands on leaves or bodies of plants, then they take up that energy. They like wiggle, you know, like trees moving, plants moving in the rain, so beautiful. And then the raindrops just slide down and hit the ground very softly and very gently. Vegetation increases condensation. So that's the capacity for water vapor to collect and form drops heavy enough to fall as rain. Vegetation increases that condensation in a number of ways, which increases evapotranspiration and adds to rainfall. Okay, so this is why I had this slide first. Forgive my caffeinated state here. Let's just take a quick visit to the hydrologic cycle here now, and we'll come back to plants in a minute. So middle school science classes generally address the hydrologic cycle in some very vague overview terms, like water vapor rises off the ocean, it condenses as clouds, it falls on the landscape, it rolls back down into the ocean, right? Okay, so yeah, everybody kind of gets that, but really that's only half of the story. And another one of my inspirations is Victor Schauberger. And this graphic right here is a drawing that I did from Victor Schauberger's book. And he was an Austrian scientist from the 1800s, or a forest warden, actually. He wasn't technically a scientist. But he pointed out, like, hey, there's actually another half to this whole hydrologic cycle. Yeah, water vapor is evaporating off of the ocean. It rises up into the sky. Under certain conditions, it's able to gather into drops that are heavy enough to fall down as rain. When the rain hits the surface of the planet, ideally it hits plants, trees, right? As we've just mentioned, they slow the kinetic energy. They allow the rain to fall onto the ground gently. There's all of these other, you know, detritus and pore space and all of this stuff. And then that water soaks down into the ground, and it soaks down and it soaks down. And some of it is just like a moist subsoil, right? Some of it goes into aquifers and is stored for, you know, a year, 10 years, 10,000 years, 100,000 years. Some of it moves through down into the ground and then finds kind of rocks and cracks and spaces and different layers where it can kind of slide along and build up pressure and come out as artesian springs and things like that. But it's super important to note that millions of gallons of water used to be stored in our landscapes, in the continents themselves. They were saturated and they held water. And that water now is not able to sink in through the surface and be stored in the earth. That water is running off into the ocean. So this is also contributing to sea level rise, right? If the landscape is not acting like a sponge, if it's not holding water and the water is all rushing back into the ocean, then that is contributing to sea level rise. It's not just about the melting of the icebergs and things. But anyway, eventually, yes, the water moves at whatever speed, taking seconds to millions of years to make its way from the sky back out to the ocean. And it should be spending like really a long, 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 long time in the earthscape. So the capacity to soak into the earthscape is dependent on this vegetative cover. So the vegetative cover keeps the ground cooler. And Victor Schauberger, who I mentioned just a minute ago, he did a lot of work with temperature that's been largely overlooked by hydrology in modern times. And he found that ideal penetration of water happens when the water is just a little bit warmer than the surface of the earth that it's landing on. So a forested landscape, we have rain that's just fallen through the lower atmosphere and kind of warmed up and then moved down through the trees onto a shaded, cooled ground surface, and it soaks right in. A totally devegetated landscape, all bare and exposed, is super hot. And so the rain is falling onto this super hot landscape. You can see this yourself when you go out and water your garden. If it's a hot afternoon and the sun has been shining on the ground, you will see the water pools and it runs away, even if you've got mulch, right? It's resisting soaking into the ground. Whereas if you are in a kind of early morning or a late evening time frame and you can see that the ground is shaded, you will notice that water really being drawn in right away. So the surface is cooled by vegetation. We have this infiltration and groundwater recharge as that water, with the help of the vegetation roots, the microbial community that the vegetation is feeding and supporting, they create this pore space and these openings so water is able to penetrate down. Then those trees, they're drawing water in through their roots, bringing them up through their bodies, through their physiology, interacting with all of their different processes, and they're releasing that water back out those stomata. You remember those stomata? So the excess water vapor from all of these different processes gets exhaled. So it's like tree breath or tree sweat or something like that. But basically, massive volumes of water vapor rise out of plants all the time, and in particular forests, which have all the different canopy layers and the understories and all these different things, and everybody's exhaling water vapor, right? So this water vapor rises up into the sky. Now, we have water vapor rising up into the sky from the forest, and we have water vapor rising up into the sky from the oceans. And now let's clarify our vocabulary. When it's just changing from liquid to vapor from heat energy from the sun, that's just evaporation, right? You leave a bowl of water out in the sun, it disappears. It turned into vapor, it evaporated. The release of water vapor from the plants, that's called transpiration, right? Like exhalation, respiration, transpiration, right? The plants are transpiring. So the combination of water evaporating off of surfaces and water being released from plants is called evapotranspiration. Evapotranspiration cloud formation is different than straight up evaporation off of the ocean. So let's talk for a minute about what makes raindrops form. Okay, and then I'll see maybe if we need a break for some questions. So when water vapor rises up into the atmosphere, it's just kind of floating around up there, and it needs something to coalesce around. All these different water vapors, they need something to gather around to help them condense to make these raindrops that are big enough and heavy enough to fall as rain. So there are three main things that encourage this precipitation formation. And these things are called condensation nuclei. And they are salt, ice or cold, and then microbes. So you can see, if you've ever had a salt candle in your bathroom, I totally made this mistake. It like sucks water from every time you take a shower or a bath, and it ends up making this pool, and you can destroy wooden cabinets and things. Okay, so, and your salt shaker gets all moist, really soaks up the water, right? So this is something we can relate to. Like, yeah, oh yeah, salt, it draws water. It's hygroscopic, it draws water. Okay, cold things draw water. Huh, interesting. Yeah, when you have a glass of ice and you have it sitting on a table on a warm day, water condenses on the surface of the glass and then, dribbles down and pools and makes a stain on your table. It's raining on me right now. I just want to say, I think I'm going to be okay. It's pretty light. The computer's fine. I'll let you know if I need to make a quick venue change. But see, I was talking about it and it had to happen. So cold, so ice crystals, if the water vapor rises high enough in the atmosphere that it becomes ice, then as it's kind of swilling around down up there, other water vapor will gather to it. But here's the best condensation nuclei is microbes. And in particular, there are bacteria that live in the stomata of the leaves in the forest. They get carried in the water vapor that's released in transpiration, and they float up into the atmosphere, and they are like, hey, mega hygroscopic, like water vapor, come to me, let's make droplets. And what happens is that water vapor is able to condense into droplets at a much lower altitude and a higher temperature, right? It doesn't have to go up so high to become ice crystals before it can make rain and fall down. It can go just like medium high. And so we get rain, low altitude rain that's really locally focused, okay? This is super critical. When we plant more trees, we increase the volume of these hygroscopic condensation nuclei that are microbes, and we get rain. Isn't that awesome? So that's our low height cloud formation and gentle precipitation. And then here's the last thing about trees. Let's go back to here. Okay. The tree roots, right? Remember I told you they're photosynthesizing, they're constructing these carbon compounds out of the carbon dioxide in the atmosphere, combining it with the solar energy and the water and everything. And they are making these carbon compounds that they secrete out of their roots. Up to half of what they make through photosynthesis, they secrete out of their roots. Oh, why? Oh my God, they're feeding a whole world down there. Millions and millions and millions of bacteria thrive on these root exudates. So the #1 preferred food of soil microorganisms. I gotta go inside. Oh my gosh, this is really funny. The #1 preferred food, plant root exudates. Okay, this is super amazing. All right, I'm gonna keep talking and just grab my books. Okay. This is so great. Okay, so plant root exudates are feeding bacteria in the soil, feeding fungi in the soil. The fungi and the bacteria are feeding everybody else in the soil. And all of these different organisms, nematodes and protozoa and all the different micropods that are down in there chewing on everything. And oh, whoops, I gotta get the flip chart. I'm gonna just keep talking. They cruise around and they make the pore spaces in the soil. So the plant is secreting carbon compounds that feed microorganisms, and the microorganisms just are leading their lives, and they're moving around and they're eating and they're being eaten, and the process of living is creating the pore spaces in the soil that allow the water to move through, that allow the air to move through, because these are animals. These microbes are animals. They need to respire. They need to take in oxygen. If there's no oxygen in the soil, no microbial life, right? But then this is carbon, folks. This is carbon. Carbon that is being sucked out of the atmosphere and secreted through roots and taken up by soil microorganisms, and then it stays in the soil. And here's one more fun fact before we break for questions. 1 gram of carbon in the soil allows 8 grams of water to be held. So if we are planting plants and those plants are secreting their carbon compounds and they're feeding microbes, the microbes are taking those carbon compounds and cycling them just by being eaten by somebody else and pooped out and eaten by somebody else and done this and done that and the other thing. All that carbon changes the structure of the soil, makes it spongy and springy and like really nice, like a sponge that can hold water. So just imagine walking in the forest, the feeling of that soil underneath your feet and the kind of fibrousness of it as you stick your hands in there. That is a sponge, and that holds water. So plants with water hold carbon, which changes the soil, which allows it to hold more water. So this is really like which comes first, the chicken and the egg. It's really hard to say, except that in my experience, I found that you can't get the plants to grow unless you can get the water into the soil. And so we have techniques for that will come in a later section. But okay, I am gonna stop. I wanted to say one more thing, but I'm gonna stop for questions real quick. So are there any questions?
Yeah. And just if you could raise your hand in the participants section if you have a question, and we will unmute you. Doesn't look like there's questions yet, Lydia.
Good, good. I'm just turning off my computer a tiny bit here.
Whoa, Charles, we've got Charles.
All right,
Charles. I'm trying to, I think you have to unmute yourself. Wait, lower hand, unmute. Oh, okay. Get rid of Charles. Maybe he accidentally raised his hand. Thank you guys for being patient with all this. I think he maybe, he accidentally raised his hand because he's not on.
Okay.
Keep going.
It is really full on raining here in Santa Cruz, and it was supposed to rain last night and it like kind of sprinkled a little bit. So this is a lovely, slightly inconvenient, but I welcome. It's like, okay, it's dumping. Just know that it's dumping and I will take full responsibility. Okay. So where did I want to go from here? We've just really gotten into the plants. They're taking the carbon out of the atmosphere. They're pumping it into the soil. It's being taken up by microbes who are working it and transforming it and incorporating it into the soil structure, which changes the texture, opens it up, makes it more springy, more porous, allows it to hold more water like a sponge. And I'll refer you to a cool video later when I get to my part about Brad Lancaster. But here's the other thing about water and heat transfer on the planet. So everybody knows, of course, that when you're in the shade of a tree, it's cooler. You know, if you're standing out on a parking lot, oh my God, the radiating heat from the sun, like, it can be really unbearable. And then you go stand in like a field, a farm field, right? Okay, slightly better than the parking lot. It's usually quite a bit steamier. Like you can feel the water vapor evaporating out of the soil and you're kind of like, it's hot and muggy in a field. Okay, well, now how about like a grassland? Okay, a little bit cooler, right? Some more widespread cover. But what about a forest? You step into a forest, whoa, you can have like a 20-degree temperature difference just, you know, within 10 feet, stepping under the edge of a forest canopy. Okay, so yeah, of course, Lydia, of course it's cooler because there's shade, right? But if you put up an umbrella next to a tree, which is cooler, like under the tree or under the umbrella? Well, under the tree, right? Well, is it really that the tree just casts better shade? Like, well, maybe there's layers of leaves, you know, it's like more than the umbrella. Yeah. But here's the thing, back to that middle school science class that we may or may not have all been paying attention. When you change the phase of water from liquid to vapor, heat is consumed, right? You don't get evaporation when it's too cold. You get evaporation when it's hot. Oh, the liquid water absorbs heat. It excites the molecules. They start moving faster and faster, and eventually they overcome their draw to each other. They're very polarized, so they like each other. They want to hang out. But the increased energy from the sun excites them to the point where they overcome their attraction to each other, and they launch out on their own. Okay, so the water vapor rises, and it's taking heat with it. Right? So the heat of the sun, when it lands on a lake or on the ocean or on a mass of vegetation, which is really just like a body of water covered in little carbon sleeves, that water heats up and it becomes vapor, and that vapor rises, and you're essentially carrying the heat away from the surface of the planet. Because to make vapor out of liquid, you must have extra heat. It consumes heat. Okay, so the vapor goes up into the atmosphere, and it goes up and up and up until, you know, it gets condensed around a microbe or an ice crystal or a salt molecule. And then it condenses, and when it condenses, it releases heat. Heat is released in condensation. Heat is consumed in evaporation and released in condensation. So the heat has been released way up there, way away from us, where we're having a heat island effect and record high temperatures and whatever. It's a great mechanism for taking heat from the surface and releasing it out into the atmosphere. Hallelujah. Look, the whole planet evolved with these processes that are based on vegetation, soil, and water in order to stabilize our climate, in order to move heat from one part of the planet to another part of the planet so that nowhere is too hot and nowhere is too cold. So this is amazing. Now, let's try to remember what I'm talking about here in the grander scheme of my slideshow. Okay. So back to the beginning here, let's see if we covered everything. We're increasing soil capacity to hold water and carbon by building soil and improving vegetative health. We're cooling the surfaces, reducing local temperatures through evapotranspiration. We're stabilizing weather patterns through the biotic pump. Okay, we'll get to that in just a second. We're slowing sea level rise by retaining the water on land. We hit that one. And we're reducing atmospheric carbon dioxide by sequestering the carbon in the soil and in the plants. Okay. So here, just because I put this slide in the beginning because I wanted to share it with you in the beginning, which I've missed, but let me just show you this slide of inspiration and resources. So I've mentioned Victor Schauberger, I've mentioned Brad Lancaster, Walter Jena. So I've had a very hard time figuring out how to say his name. I just realized my cell phone's still out there in the rain. All good, all good. Walter Jena, he's an Australian scientist, microbiologist and soil scientist, and he worked for some of the large research organizations in Australia. And his new baby is the Healthy Soils Australia initiative. And he has the details and the facts and the figures on the tip of his tongue, and you can look him up on YouTube and see a 2-hour lecture on these things that I'm going through really quickly right now. So he has been a tremendous inspiration to me, and he stands up with a whiteboard pen and just like puts it all up there live. You know, I got it all pre-drawn, but he's just amazing. And he's teamed up with Dee Dee Pershouse, who's an MD, an American woman from the East Coast, and her organization is called the Soil Carbon Coalition. And she is really like heavily educating on this soil carbon sponge, this way that plants secreting the carbon change the structure of the soil, make it more like a sponge, which enables it to hold more water, which enables it to support more vegetation, which enables it to sequester more carbon to really increase this whole process, right? So check out those two. They do like workshops together. There's a number of YouTube videos that are free and accessible that you can go to for more info. And then there's Brad Lancaster, more on him coming, and Victor Schauberger, more on him as well. And we've done the hydrologic cycle, and we've talked about the trees. Okay, bigger picture, forest interactions with climate. Here we're gonna hit on that biotic pump piece. So on the hydrologic cycle slide, we saw about the oceanic evaporation and then the evaporation from the trees, right? So now let's look at this a little bit wider view. So when there had been less interference with the landscape by humans, when we had done significantly less clearing of forests and paving, desertifying, compacting, industrial agriculture, you know, all these things that are kind of normal now. Before the advent of all of that, our landscapes were much more forested. And a lot of the areas now that are desert used to be forests, you know, Afghanistan, Syria, Tibet, you know, and now California is on its way to becoming a desert. And this is what happens when you clear forests. But okay, so prior to that land management, widespread land management mistake, water vapor would rise off of the ocean. It would ascend into the atmosphere. The salt crystals and the cold would allow it to condense, and it would fall. And in the meantime, it's kind of moving over the landscape, right? So then it falls as rain, falls on the trees, they softly, gently buffer it, it falls down to the ground. There's all of the detritus and the humus and the organisms and the roots and et cetera, and it soaks in and it gets drawn back up and evapotranspired and it goes back up into the atmosphere. And you can see like, oh, there's these little kind of loops of atmospheric layers where water vapor is rising, condensing, falling, rising, condensing, falling, rising, condensing, falling. And as we move further and further inland, a higher and higher percentage of this water vapor is from the vegetation and less of it is from the ocean still. And so, you know, Victor Schauberger, 100 years ago, he predicted this climate change and desertification from forest clearing, basically. And he said this oceanic evaporation, it's really raw, you know, it's just water. Like the evapotranspiration coming out of the forest, it's full of all kinds of things, like little remnants of the physiological byproducts in the cytoplasm of the trees. And then it's rising through these canopies and picking up bits of poop and dust and fungal spores and bacteria and all these things. So it's a much more complex, it's not just pure water vapor, right? But the reason why water vapor makes it inland is because of this cycling, this leapfrogging spiral that happens, this little sideways spiral. And when we begin to cut the trees, we totally interrupt this cycle that carries water vapor inland. And so we, there's this compounding effect, right? If you cut trees, obviously, then you have a bare landscape, but the baring of that landscape isn't just affecting that landscape, it's affecting things further inland. So as we deforest our continents, we get more intense rainfall on the coasts that then becomes flash floods and runs very quickly back out into the ocean, and then that cycle just repeats. So we have these violent storms on the coasts, and we have droughts inland. And once you get to the point where you've deforested your coastal mountain ranges, has anybody done that? We're in deep trouble. Like, it's really hard to reforest these mountain ranges once we have changed the weather patterns and there's not enough rain anymore. So this is like the big challenge. We can understand the problem, and we all here now understand the problem, and many other people do as well, but somehow the people who are making decisions and doing a lot of public educating do not seem to understand the problem. But okay, we do. Fix it. How do we fix it? Like, once you've changed the surface of the earth and the rain is no longer falling, how do you reestablish a forest? So we're coming back to that later. But this is massive, right? And then here's the piece about the biotic pump that was in the first slide. The rising of water vapor off of the trees, off of the forest, it actually creates a little bit of a vacuum, which sucks more moist air in off of the oceans, right? So it's like biology creating a pump, like drawing up, sucking in, drawing up, sucking in, drawing up, sucking in. And it's not just this evapotranspiration thing. There's condensation that happens because moist air is being drawn in from the ocean through the trees, and the leaves of the trees act as condensation surfaces because they end up being cooler because they're just like all by themselves out there in the wind. And so water vapor condenses on the leaves and drips down. So it's so multifaceted, all of the ways that bodies of vegetation allow water to interact differently with the earth. So that was the last piece from the first slide that I wanted to just make sure we hit on, was that this rising vapor draws in more moist air, which is then condensing more on the leaves and dropping down. And so this condensation bonus that's not even counted as rain can be up to 85% of the rainfall when all is said and done. So that's pretty amazing. All right, what can we do? So in order to restore the infiltration capacity to impermeable soil surfaces, we have to come in with some healing techniques, okay? So bare soil is very, very challenged. It has an extremely difficult time absorbing water and supporting vegetative life. And just incidentally, the plants that many of us vilify, the ones we call weeds, they are the ones that can handle that condition, that totally bare, totally extreme, too hot, too cold, too dry, too wet. Dandelions, right? Dandelions are our friends. Let's celebrate the dandelion. Nice taproot goes down in there, pierces the compacted soil, covers, makes that rosette of leaves, makes this nice protected area, creates little homes for other creatures to get in there and start cycling vegetative matter, organic matter, etc. Okay, so just an invitation to take another look at weeds and how you feel about them. But really, the weeds are stage one of what could be a 100-year process of restoration, if allowed to happen on its own. We do not have 100 years. So first, let's stop pulling our weeds. And then let's talk about mulching and earth contouring in order to create spaces for water to soak in. So one of the main problems is with this like super impermeable surface that we've created is that the water hits it and it just rushes off so fast. It's so fast, like it didn't have any time to soak in. And the water's like, oh, I really kind of wanted to hang out, but there was a slope and so I had to go. So we can create basins, we can create trenches, we can create other places to catch the water, to hold it for long enough to allow it to soak into the earth. And so one of my absolute favorite techniques is the swale and berm. And Brad Lancaster talks a lot about swales and berms, and he calls them berms and basins. And that is because the word swale is used to mean different things in different contexts. as you know, language is so fascinating. But these are Brad Lancaster's books right here, Rainwater Harvesting for Drylands and Beyond. And then this, the second volume here, this is the one with the major info on earthworks and stuff. Also a section on gray water. Super accessible, super detailed, great diagrams, really approachable. Highly, highly recommend this. And more on that later. But we restore the infiltration capacity to impermeable soil surfaces by creating spaces for the water to sit. And so the swale and berm is basically just a long trench where you take the soil out of the trench and you pile it up on the downhill side. So these are usually done on a slope, and there are parameters around, you know, how steep is too steep, and well, what if you have an impermeable clay layer underneath or a bedrock layer or something. So there are situations where swales are not appropriate. But if you have a nice gentle hillside with some pretty good depth of soil, you can dig long trenches and take the soil out of the trench and pile it up as a berm below. You can see in this diagram. And, you know, I shape it all nice, make it real pretty. Now you have this beautiful berm that's like fresh soil, ready for whatever seed mix you've got, and planting in trees, native trees, fruit trees, shrubs, understory, all different layers. Like you could fully do a whole food forest on your berms, long skinny food forest. But basically the water that's running down the hill, see a little hilltop cartoon there, it gets caught in the trench. And now the critical piece of the swales is that they are on contour. And if this is an unfamiliar word to you, think about topographical maps and all those little squiggly lines, and they have numbers on them. And so theoretically, every point on that line is the same height above sea level. And if you walked on one of those lines, you would not be going up or down, you would just be walking flat. And if you dug a swale on one of those lines, it would be a very effective swale, because water moving downhill would gather in the swale, it would fill up like a long skinny pond, and then it soaks in. Now in larger landscapes, people build swales with tractors, and they're 6 feet wide and 3 feet deep, and the berm is huge. And those are structured to be very gentle sided. So it's a more subtle feature on the landscape because of the angles of the walls and everything. But in small landscapes where I work a lot, like residences, I make straight walled kind of U-shaped swales, and I fill them with wood chips. So see in the lower part of my diagram here, the swale, and you can see the little water lines there, and then the blue arrows indicate that water is soaking in. So I would fill that whole area there with wood chips. Now, that really like jump starts the functionality of the swale, because it's what's keeping the walls from collapsing. So I can have a nice amount of water holding capacity in a small space. Because I'm holding it open with the wood chips. And the wood chips, I like big chunky ones, you know, and they've got a lot of space between them, so they can hold a fair amount of water. Then they actually are absorbing the water too, so they're kind of spongy in and of themselves, not initially, but over time. And then they're keeping that soil cool underneath them. There's like, you know, basically 1.5 feet of wet wood chips then in there. And then that's carbon that's feeding the soil microorganisms. Oh, soil microorganisms again. Okay, so their number 1 preferred food source is plant root exudates, but their number 2 preferred food source is dead organic matter. So they will happily eat, you know, your chop and drop leaf mulch and your wood chips and etc. So you've just created this beautiful reservoir where water is being caught and held for long enough for it to soak in. It's not being impounded. There's no barrier. We're not trying to hold it. We're just trying to slow it down. And then we filled it with microbe food, and we kept it cool and moist. And then you plant things on the berm right next to it, and their roots are able to go down and access this new zone of saturated soil that we've created from the berm. And now you have all of these other microclimates. Now you've got a sunny side and a shady side, and a dry side and a wet side, and a high side and a low side. And so you've created all these new niches for all these new organisms. And let me tell you, diversity is the key. The more different kinds of plants you can have, the more different topography you can have, the more different microbes you will get, and the more water holding capacity and carbon holding capacity you'll have. So, so that's awesome, right? So this is something you can do by yourself or with a small group of friends. And in the video that we made with Nicole and David, you know, we talked several times about the swales that were installed in those front yards and backyards in order to take the water, the roof runoff or the gray water, depending on the situation. And then we had those super thriving plants, right? So bigger context here, how could we apply this technique on a wider scale in order to somehow replicate that function that the forest was providing between the ocean and the coastal mountain ranges in order to cycle the water vapor? Well, what if we just planted bands of trees on contour along our coastlines, and then the moist air coming in off the oceans would be intercepted by these bands of trees, and we would have that condensation, and we would have that additional water drop, and it would fall right into the swale that was right there next to that band of trees, and it would go down and be this saturated zone of soil, lens of soil, which would then be drunk up by those very same trees and retranspired up into the atmosphere with the accompanying microbial condensation nuclei, which would then allow rain to fall very close by at a very low altitude, and then you're changing your local climate. You are changing your local climate. So at this point, people usually want to know, how many do you need? Like, how many trees? What density? How much? How much? How much? So Walter Jena gets asked that very same question. So I'm going to cheat and use his answer. So he has an example where there was a guy in Indonesia. Okay, so different climate than California, but he had an orangutan sanctuary, and it was 5 square miles, and he reforested it for the orangutans, and the result was a 20% increase in local rainfall. Then there was a gal at one of Walter's seminars who said that she knew of an example that was only 17 acres. And then Walter said, you know, a row of sequoias just below the ridgeline would do this very same thing. So basically, we don't have the detailed research at this point to answer the question of like, what's the minimum right now? But if you check out some of the experimentation that's happening in Europe, and here's another resource that I realized I didn't have on my my little resource page there, but this is a website. It says on here, Water for the Recovery of the Climate, but the new name of it is Rain for Climate. It's a group of Czech and Slovakian scientists, and they have now research sites all over Europe where they've done earth contouring for water infiltration with a replanting project, and so they are collecting data. They have great cartoon graphics about how this is all working, with many, many additional layers of detail that I don't have time to go into. And yeah, it's just super inspiring. And they've got a whole timeline of how they're rolling out this whole program, and that we can really change the climate of our planet by changing the way that we manage the water cycle. So that's a lot. And I want to like bring it home right now and say that it's actually our management of water and not the carbon dioxide concentration in the atmosphere that is screwing us over right now. The concentration of carbon dioxide in the atmosphere is correlating with our climate change, but it is not causing it. That carbon dioxide in the atmosphere is responsible for 4 to 5% of the heat movement processes on this planet, and water is responsible for 95%. And then there's 1% with like methane and whatever, right? But so why aren't we paying more attention to the water? Why are we so fixated on the carbon? Well, the question was asked in the 1950s, like, you know, what's happening with the burning of fossil fuels and the carbon? And it was Jimmy Carter, and, you know, he got some scientists together to try to figure this out, and they came up with that chart, right, where in the northern hemisphere during the winter time, our carbon dioxide concentration spikes, and then it drops down in the summer, and then it spikes in the winter, and it drops down in the summer, and it spikes in the winter, but the general trend is up, 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 right? Okay, so just quickly thinking through what we've just learned, we can say, oh yeah, in the summer, all of the trees are photosynthesizing like mad beings, and so they're sucking down all this carbon, and so yeah, we have like a drawdown in the summer, and then in winter we're all burning whatever, keep warm, blah blah blah, not so many leaves, and then we have this release. So we draw down, and then we release, and we draw down. So oh my God, the plants are doing it. The plants are the ones that are making this happen, but we're tracking carbon dioxide, and so we think it's all about carbon dioxide, but actually it's the plants that are doing it, but it's all about water, right? It's all about water. So we're tracking the carbon thing because it's easy to track. It changes more slowly. We have a lot of data on it. And water vapor concentrations in the atmosphere change from hour to hour, minute to minute, like really complex. Like the modeling was just a nightmare. And so we fixated on the carbon. But I just want to put it out there that from my research, what I've read over the last 15 years, carbon is just correlating with climate change. Carbon is not causing climate change. Now, of course, we want to reduce our emissions. We want to get the pollution out of the atmosphere. That's absolutely true. But we've already gone too far. Like I'm sure you all know this, like we are not even experiencing the effects of the carbon that we released 20 years ago yet. And so if we stopped all carbon emissions now, we're still pretty well screwed. But if we can stop this mismanagement of the landscapes and start healing the Earth's surface and allowing the water to soak in and revegetating, and we do not have to knock down whole metropolitan areas and replant them in forests. We have to strategically plant and perpendicular to onshore winds and, on the contour and all these, little details that I've just mentioned. We strategically plant and we can replicate these patterns that were keeping our planet cool for millions of years. So how about another question break?
That sounds good. Let's get to Mr. Charles. I'm going to unmute you. Sometimes it takes a minute. If you have any questions, just raise your hand in there.
Can you hear me?
Yes, Charles, we can hear you.
My question is about the nuclei. So those are nuclei from like fungi, or those are microbes, like living creatures that go make the rain lower in the atmosphere?
Yeah. So my understanding is that it's bacteria. And yeah, there's like some mysteries still. Bacteria normally clump together in, kind of wads, and it's not so easy for them to rise up in water vapor. And not all plants are able to do this. Like grasslands, it doesn't seem like grasslands are able to release this particular kind of bacteria. It's only forests. So something is happening in the forest, and I don't know whether it's about the altitude that it's being released at or what, but somehow these bacteria are traveling in the water vapor, and it's actually not the bacteria themselves, but these carbonaceous secretions that they make that are so hygroscopic that they are like sucking water into them. And so yeah, they suck water towards them and they make droplets that are heavy enough to fall. And I just think that's the coolest thing ever.
Thank you.
You're welcome.
Thanks, Charles. And then this one doesn't have a name, it just says iPhone. Hello.
Hi, can you hear me?
Yeah, we can.
You talked about mulch, wood mulch. Do you have any issues with like termites or those creatures that are not too good for for around your yard?
Yeah, I have not experienced any issues with termites from the mulch. Snails and slugs, yeah, like when you mulch heavily, you'll have more snails and slugs, and that's challenging in the springtime. The biggest kind of threat to houses that I found from engaging in this process is that when you start mulching and you dig your swales and berms and changing your soil structure, raising okay. Like not only because you're adding mulch, but because when the carbon is incorporated into the soil, it becomes like fluffier. The volume of the soil actually increases. And so if you started out on a flat property and you did all of this, you will find that your house is now in the bottom of a bowl. And so because our houses were already, most of them built kind of not high enough off the ground, there can be issues with the moisture underneath the house in the crawl spaces. And in Santa Cruz, most people already have a pump underneath their house to get the water out of the crawl space. And so in those situations, I don't worry too much about, more water, because as we change the soil structure, it's not only holding it more easily, but releasing it more easily, like letting it move on in a good way and supporting more plants and just generally modifying the climate, as opposed to creating a sodden, messy reservoir of saturated soil. the soil that's actually underneath your house is the last part to transform, because it doesn't have the actual plants in it. It's just adjacent to plants and things. So that takes a while. But yeah, you know, we don't want to construct swales closer than 10 feet to a house unless they're downhill from the house. Then, you know, the water that's infiltrating is moving away. Uphill from a house, I would not do an on-contour swale. I would do like a gently off-contour swale, you know, kind of like a French drain-ish kind of thing, to move the water away from behind the house and off to the sides to a safe place to infiltrate it. So if you have a situation where you are too close to the house, then you make your swales slope a little bit to like shunt the water gently into a good place. If you live on a really tiny property, sometimes you have limited options that can be rough, but usually you can make even just a really shallow berm and just like very selectively plant things around that. But termites I've not had any issue with.
All right, Lydia, we've got one more question here. It looks like it's Julie. Hello, Julie.
Hi, everyone. I just wanted to respond also, if I could, to the last question regarding termites, because I had ground termites right along my garage where water dripped off the roof. And you can get beneficial nematodes. A particular kind to eat ground termites, and do an application and pour them in, and the nematodes will eat the termites or destroy them, and then you've got these wonderful beings in the ground as well.
Nice. Thanks, Julia. Yeah, I mean, what I find is that like a surge in any kind of particular organism is a temporary thing, because we're creating the conditions for life. And so what ultimately happens is there's just a massive diversity. So you might have a temporary surge, and one of my teachers, Hazel Ward from Siskiyou Permaculture, she calls that an ecospasm, right? So we have a temporary surge in one particular species, we have an ecospasm, and there's a little lag before the other organisms that keep that organism in balance kind of come into effect. And, you know, you've probably experienced this with aphids. Like you get to aphids and you're like, oh my God, where are the ladybugs? Where are the ladybugs? It's been a week. It's been 2 weeks. Okay, sometimes it takes them 2 weeks to find the ladybugs, but you got to be patient. You can't spray it with poison. You have to just wait, and then the ladybugs come. So thank you, Julia. Any other questions?
Nope, looks like we're good. So
excellent.
Oh, wait, hold on, there's one here.
It's me again, Julie. I don't know if you did. Can you hear me?
We can hear you.
Yeah, I love the idea of healing using contour planting along the coastal mountains. I just wonder about where we are right now with the fire danger. We're in this drought, and we're getting these massive fires. And is there, I guess my question is there any large scale work politically or anything? I haven't heard about this before, and it's wonderful, but is there any group of people behind this movement that we can kind of chip in energetically or monetarily or whatever to help get it going?
Yeah. So the Rain for Climate folks that I mentioned, and this was just a downloadable PDF off the internet. I forgot to mention you can get this for free. You know, they are putting together a very strong political coalition, but that's in Europe. Walter Jena, with his Healthy Soils Australia, I believe is gaining some political clout there. And then I know there are some smaller things happening in California, and as you know, as our wildfire situation gets more and more serious, if we can, you know, have some of this evidence from other places to really be able to make a good case, you know, I think we'll gather support and momentum and funding. But yeah, I mean, as you've probably surmised, the forest fires are not just because the weather is so hot, it's because the forest body is so dry that there's not as much moisture in the soil. So the trees themselves are really struggling with less water in their bodies, and that makes them more flammable. So any way that we can support our forests via infiltrating water into the landscape, that's really going to help, and that's really going to reduce the fire danger and the severity.
Thank you.
And Julie, will you do us a favor and put the resource in the chat for everybody to where you found the ground nematodes?
Yes, it'll take me a moment.
Yeah, that was one of the questions. And let's just take one more question, the raised hand of the iPhone. Hello?
Hi, it's me again. I asked about the wood chips. I live in an area on a hillside, so that the berm and the soil seems like a perfect thing to do in my yard. But we live on a very rocky soil. I dig down. It's only like maybe 4 inches before we hit the rocks. And so what we've been doing is putting straw bales, but the straw bale doesn't last too long, and when it does break down, it's down to nothing and turns into dust. And we're on a very windy area. When the wind kicks in, it just blows everything, and our house is always dusty. But I guess my question is, what would be your solution to build soil on top of a rocky terrain?
Yeah, that's a great question, because yeah, not only is it really challenging to actually dig a swale in soil like that, but if you have bedrock down that shallow and you're super saturating that soil, you could potentially create a liquefied soil situation that then just slides right off of that bedrock, which is obviously not what you want. So establishing, tough, like pioneer plants, woody plants, in particular, if they have a relationship with soil organisms that allows them to sequester nitrogen and put nitrogen into the soil, that's great. And I'm not sure what part of the world you're from, but here in California, we've got ceanothus, which is a nitrogen fixer and a tough woody plant. We've got the coyote brush. We've got, stuff like that, where we can kind of get things going that are really tough and can handle those conditions. Will hold on to that soil. And if you plant them on the contour, instead of digging the ditch and making the berm, you just plant, then they will actually be creating a mellow barrier, not super saturating the soil as much, but just slowing down that water. And whatever the water is carrying with it, topsoil from uphill or mulch, leaf matter, caterpillar poop, whatever, it will start to get caught up behind your band of planting on contour, and then that soil will.
Right. And so basically, either it's going to be a boom or.
In my next segment, I'll talk a little bit about an example from Zimbabwe. It was Brad Lancaster's first inspiration. This man, Zephaniah Piri Maseko, and how he worked with contour without initially digging swales and berms. There's also another system that's a broad acre system called keyline design or keyline planning. And in keyline, you're working slightly off contour. And so you're more like moving and redistributing the water laterally and not just infiltrating it directly on contour. And if you want to get into like permaculture controversy, you can check out two Australian permaculturists, Darren Doherty and Jeff Lawton. And Jeff Lawton is all about swales and Darren Doherty is all about keyline, and they get into it and you can hear all of their different pros and cons, and really just kind of depends on the specific situation. And that's permaculture, like it depends, everything changes everywhere you go. And so permaculture is about a set of principles that allow us to make good decisions and not about recipes. So I really appreciate when people ask questions about situations that aren't necessarily so applicable for swales. So it reminds me to say like, oh yeah, this is just one example that I have found to be really approachable and doable by individuals and small groups that can make a huge difference and is applicable on a residential scale. And so that's why I really like to highlight the swales and berms. But there are other variations on this technique for different soil types, different slopes, different scales of working. So I hope that answered your question. Oh, also, if you do have fallen trees, you can take those trunks and just lay the trunks on contour. Any brushy material, if you're limbing trees, you know, removing the lower branches and stuff for fire safety or, you know, access or whatever, to take those branches and lay them on contour, or to take wood chips and lay them on contour. But yeah, your straw bales on contour, that's an awesome idea. The dust is a problem, but what else could you lay on contour that would be maybe less lightweight and airborne?
Awesome. Thank you, Lydia.
Yeah.
So I think we could go back to the presentation in it, like for, I don't know, another 20 minutes, and then we'll stop again.
That sounds great. All right, so let's see what's coming up next year. Okay, so just a little bit on Victor Schauberger, and then I really want to focus on Brad Lancaster as, like, you know, kind of more accessible techniques and approaches for individuals. So Victor Schauberger lived from 1885 to 1958. He was an Austrian man. He was known as the water wizard. His family motto was Fidus in silvus silentibus, faith in the silent trees. Like, that's the most beautiful thing I ever heard. And his personal, you know, teaching phrase, like permaculture principle, was comprehend and copy nature. And he spent his whole childhood as a dreamy lad, wandering the Austrian Alps, observing things, observing water mostly. He ended up working as a forest warden, chasing down poachers and things like that. But what he really devoted his life to was understanding how water works and healing the way that we are managing water. And so, you know, we didn't really manage to take up his advice. He was a little bit ahead of his time, though. People couldn't understand him, and he didn't want to go to university because he really didn't want to pollute his intuitive, direct access to information from nature with, you know, somebody else's information. And so he didn't have the right credentials, and so in some circles he wasn't taken seriously. And you know, in the end, Hitler made him do things that he didn't want to do, and then the CIA got involved, and he died a broken man. Is really a sad story. But his gift to us, which we were not maybe ready for 100 years ago, is really alive today. Like, you know, we can really embrace this kind of thinking as our kind of reductionist materialist model opens itself back up a little bit to the world where intuition and energy and some level of spirituality can be taken more seriously, you know, right? Like quantum physics is now proving things that used to be all woo-woo, crazy, crazy, right? So, okay, so now we can look back on some things that we couldn't take in as a body of humans previously, and start to be able to incorporate this information into our understanding of the world. So he had some really amazing things to say about the way the planet works, and I encourage everybody to check him out. But, you know, he really focused on water's motion and water's temperature, and that water really, to heal itself, it needs to move in a vortex, which is, you know, a three-dimensional spiral, and that water has this kind of ideal temperature, which he called the anomaly point, which is 4 degrees Celsius, or, you know, 39-ish Fahrenheit. And that at that temperature, water is at its most dense. And this is super cool, right? Have you ever thought about why ice floats? Because every other substance on the planet, the solids are heavier than the liquids. But ice floats in water. Just think about that for a second. What if it didn't? What if ponds froze from the bottom up? There'd be no reservoir of dormant creatures like waiting for the spring. You know, everything would just be dead. So ice floats, it freezes on the surface, and it protects everything underneath it. And that makes life in the extreme latitudes possible. But why is that? Well, as water moves from its densest point at 4 degrees Celsius, where it's all the molecules are as close together as they can get, in order to freeze, it has to kind of pull away and, you know, move into this crystalline structure. And you can see air bubbles in ice cubes. So cool, right? That's why they float. But yeah, so Victor was like, hey, how come nobody's paying attention to the temperature? How come nobody's paying attention to the motion? And this is a huge bunch of super fascinating stuff about how rivers move and how to purify water and how to use water as ideally as we can for transporting heavy things without, putting it into canals and channelizing it and all of that. And there's actually a fairly new book that I just found. This one here called The Fourth Phase of Water by Gerald Pollack. And he's really talking about how the water molecules organize, and that there's actually a fourth phase. It's not just solid, liquid, vapor, but there's this fourth phase called structured water, or there's some other names for it. But that the structured water has amazing potential, that actually the water inside of our cells where our DNA is being replicated is structured water, and that's essential to the quality replication process, and that, mutations and DNA degradation and the issues we're having with our health in general and at large are, all kind of linked to the poor quality of water. One more thing I wanted to say about that, but I'm sure it'll come back to me. So that's a whole nother webinar, like a lot of really beautiful, magical stuff. But oh yeah, the last point I wanted to make was just that, we have spent a lot of time studying water molecules in isolation. How does a water molecule behave? But we have not put a lot of time into how water molecules behave socially. And that is the key to us understanding and being better water stewards, is understanding how bodies of water interact with each other and with the surfaces around them, hydrophilic and hydrophobic surfaces around them. So let that just be a little teaser for you that makes you want to go read all day instead of whatever other chores you're supposed to do after this. Okay, so moving on from Victor Schauberger. Oh, cool, teaser slide, teaser. Ooh, more teasing. I will stop here just about temperature. Victor Schauberger noticed from personal experience and really tried to spread this information. When we devegetate our stream banks and we expose them to the heat, then we have this overheated soil surface. Now, what he found was that this overheated soil side, that the water would move out of the hot landscape into the cooler river, so that a river flowing through a devegetated landscape was actually a drain, that it was drawing the water out of the landscape and bringing it away. Not only did the water leave the landscape and enter the river, but the nutrients would be leached out of the landscape as well, which is pollution. We want our nutrients in our landscapes, not in our bodies of water. So when you devegetate a landscape, then the river that's moving through it becomes a drain and a source of pollution, or a reservoir of pollution. So this whole idea, the various governmental organizations have put lots and lots of time and energy into removing riparian vegetation because it was stealing the water from the river, right? And then also channelizing our rivers so that they were more navigable and, they worked better, right? We want them to get rid of all that nasty water before it causes any property damage. Whereas the natural flow of water is this meander, and a meander is really just a flattened vortex, if you think about that for a minute. And then we got to keep that vegetation in order to keep the soil cool, because then the soil is actually able to draw water into it from the river instead of releasing water out of it into the river. So that was a little detail I had to stop on there. Okay, here we go with Brad Lancaster. Quickie overview. He's written only the first 2 volumes here, 1 and 2. Volume 3 was supposed to be out in 2019, but instead he did an updated edition on volume 2. I support him in that. But I was very interested in reading volume 3 on roof catchment and cistern systems. But he makes a really great point, and you can look up Brad Lancaster soil sponge versus tanks, something like that, and you'll get this really funny video of him demonstrating with a little to scale model house, and he takes a watering can and he pours water on the house, and it's got a little yard. It's all just made out of metal. You pour the water on there, everything washes off, no absorption. Then he takes 2 tiny little to scale tanks and he puts them under the downspouts and he pours the water on there, and yay, he's caught like,
1/8 of a cup of water, and he pours that into a cup measure, and he says, look, we caught 1/8 of a cup of water. Then he takes 2 kitchen sponges and he puts them in the yard of his little model house, right? And then he pours the watering can on there, and then he's got his 1/8 of a cup of water from the 2 tanks, and then he squeezes out each of these kitchen sponges into the tank, into the measuring cup, and he's got a cup of water. So that the 1/8, to scale, 1/8 cup of water that was stored in the tanks compared to the 7/8 cup of water that was stored in the sponge that's representing the soil, right? He's like, so why are we spending so much money on tanks when, we kind of have a tank capacity issue? We get our rain kind of concentrated in 5 months, and then we have the 7 months of dry where there's kind of nothing, so we can't refill the tanks, but we're spending money on tanks, and they're plastic, and they're all of this and that, when we should really focus first on the soil sponge, because it holds more, it holds longer, it's cheaper. And here was another little piece that Walter Jena says that I really, really appreciated, that our modern human approach is bigger, faster, right? We want bigger plants to grow faster. But what nature does is she makes everything last longer. So if you can get a plant to grow twice as big in 1 month, then you have twice as much plant mass, right? But if you can have your plant grow the same, but for 4 months instead of 1 month, then you have 4 times the capacity, right? So he was like, extend everything. Nature makes it last longer. Nature makes it slower. So what we want is the soil in the water to support vegetation for a really long period of time, and stop wasting our time just trying to make shit grow fast, right? So that was a cool point that he put in there. But back to Brad Lancaster, and I claim caffeine for all digressions and lack of organization here. So Brad's main inspiration, like what launched him on his path, was this man, Mr. Zephaniah Piri Maseko from Zimbabwe. And this gal, Mary Wodashinsky, she wrote a book about him, The Water Harvester. And it's just this beautiful story of, he got into some political scrape and then was unable to get a job. And so he had to support his family of 7 with just the land that he had. And he noticed that after a rainstorm, things stayed moister longer and soil collected and began to form behind on contour obstructions. And so he just went from there. And he designed his whole entire landscape to be a water farmer. So his whole thing was about getting water and shunting water from one place to another on his landscape. There was a massive government-built drainage ditch that was supposed to, help with flooding from monsoons, but actually just dehydrated the whole landscape. And he went inside of this huge drainage ditch, which was obviously not on contour. It was very much sloped. And he dug on contour pits and built berms to slow the water down inside of this massive pit. And then he actually ended up creating little pockets of wetlands. And anyway, his story is quite exciting, and I encourage everybody to check that out. But Brad Lancaster has come up with these 8 rainwater harvesting principles for the core of successful water harvesting. And he says every site is unique and must be approached with its own distinctive characteristics in mind. And this is true for any land enterprise that you engage with everywhere. Do not ever expect it to be the same as it was the last time you did it, or the thing that you read about, or the video that you saw, or the person that you talked to. It's different every time, which can be frustrating, I know, especially when you're just starting out, but this is what makes it so beautiful and so fun. It's different every time. So you integrate all 8 principles and the permaculture ethics, which are earth care, yes, hallelujah, please more. People care, of course, we cannot care for the earth and not care for the people, and we cannot care for the people and not care for the earth. And then reinvestment of surplus time, money, and energy to share the wealth, to continue the project, to share the good word and the message and the healing. So principle number 1 is to begin with long and thoughtful observation. And this is the key to understanding, but everything's different every time and it always depends. How do I know what to do? Sit down, make yourself some tea or have a beer, whatever you like. Get your hammock, lean against a tree. Try to stop thinking and just let yourself absorb. And we are surrounded by beings who want to help us figure out how to help them. The plants, the rocks, the soil, the ponds, the lakes, the streams, the raindrops, they all have a vested interest in us figuring this shit out. And so if we can quiet our own minds and just be ready to receive, we'll get ideas about what to do. And if we didn't get it quite right and we try it, we start small. We start with our shovels and we make a mistake, and then we sit down and we observe again, and we'll get a different idea about what to do. We'll learn how to improve simply by opening up our hearts and being receptive to what nature is here, like basically broadcasting every moment. This is how to be a human. This is how to care for this planet. It's all right here. Pay attention, pay attention. Rainwater harvesting principle number 2, practice water spread, right? So like with the key line design, you know, we're slightly off contour. We're moving water from areas of high water concentration, valleys, to areas of low water concentration, ridges, or we're taking our swales and we're taking water that would have ordinarily like just rushed down the slope and gathered at the bottom. We're stopping it mid-slope. We're spreading it out along the swale. We're letting it soak in, soak in, soak in. And we're starting as high up in our landscapes as we can. And in this little crazy, crazy steep graphic there, you know, you don't always have access to the top of your landscape or to the top of the watershed, right? You have access to maybe and stewardship over only maybe a small chunk of something. And so sometimes you can't start at the ideal place, but start as high as you can. Start small and simple. You and a shovel, some friends and a shovel, maybe after 2 years of handwork projects, then you can think about getting a machine to help you out. But once you're in the machine, you think from the machine's perspective. You're not on the ground anymore. Like it's really, I've worked with machines some, and yeah, really changes the way that you think and your capacity to receive the information that I was just mentioning, like from the world that is trying to guide us and instruct us the whole time. Stay technically and mechanically simple. Use multiple small earthworks instead of a big one. They're easier to create and they capture more water than one big dam, and they evaporate less. Like there's less water loss from 100 little basins than from one basin that's 100 times the size. Also, like this is approachable. You can do it. You do not need to rent a bulldozer. You know, yeah, some friends are great, but you know, start small and simple and learn, and it's effective. It's still effective. I mean, even if you can only take the back of a pick and just scrape a line on contour through a super hard, compacted, dry, really inhospitable hillside, right? Just scrape, like maybe it's only half an inch deep, and then sprinkle some coyote brush seeds in there. And then, you know, sprinkle just like a little bit, a handful of, you know, some kind of mulchy thing, and hope that it rains. And that will do something. Even just that small amount of impact will do something. So, and if you're really not sure what the heck you're doing and you're really worried about making big mistakes, start that small and just pay attention. Okay, rainwater harvesting principle number 4, spread and infiltrate the flow of water. Make it move, make it move, make it move, right? We don't want to go from the source to the sink right away. We have our, you know, 3-dimensional and 2-dimensional representations here, but the bottom left picture here, these are the kind of landscapes we want, right? Those blue lines going down, that's water infiltrating down from key lines or from swales, and this vegetation that's thriving is feeding on that water and then encouraging more water to infiltrate and changing the structure and cooling the earth and creating organic matter and feeding the microorganisms and. So spread and infiltrate as much as you can. If you think about the water molecule, you know, anthropomorphize for a minute here, think about the water molecule and its dreams of a fulfilling life, right? The water molecule wants to be a part of everything it can be a part of. It wants to be, you know, part of trees, part of flowers, part of ponds, part of springs, part of everything. It doesn't want to just rain and flow over the surface back into the storm drain and back down to the ocean to have like this super limited life experience. Let the water interact with as many different aspects of the planet as it possibly can. And if you just hold that in mind, like, is my water getting as many enriching opportunities as it can, right? Like think about your child, right? Like your water, how do I provide enrichment opportunities for my water? Yeah, just spread it around. And another person I can suggest, Sepp Holzer. He's an Austrian permaculturist, and he's got a a site in the Alps, and he's got like pond here that overflows into pond here that ping pongs into little running stream over here that ping pongs. And so he's really got it just like moving all over the landscape and interacting in as many different places as possible. So that's a good model. That's what we want. Okay. Principle 5, always plan for an overflow route and manage that overflow as a resource. This is a major safety factor here. If you do not plan for where your earthworks are going to overflow, the water will decide where they're going to overflow, and it's generally not the place you wanted them to overflow. And so, you know, you dig a basin or you dig a swale and it's got this nice berm. You want to figure out, okay, if this fills up, if I reach full capacity, we got a really big storm, where do I want the water to go? And ideally you want that water to overflow out of that swale and run over the ground a little bit into another swale. So you have to decide where that overflow is going to be. And then you cut into your berm and you make a wide, flat spillway in your berm that's a few inches lower than the top of your berm to allow the water to exit wide and flat, nice slow sheeting over, not a channelized, gouging, erosive channel, but wide and flat. And then it just spills over across vegetation or rocks, you know, some other kind of protective apron, into another swale. That one overflows into another swale and into another swale, and then finally into just a vegetated berm where that water can soak in and dissipate. And so then, you know, it's kind of the ping-ponging thing, right? And a safety thing. And, you know, a lot of folks with tanks make the mistake of not having the overflow water from the tank directed into an earthwork. And it's probably at the edge of their property somewhere, and it just erodes as it spouts down out of the top of the tank and hits the ground from 8 feet away and creates a little gouged out pit, and then begins running a channel of erosion that ends up on their neighbor's property and causes a landslide and the, you know, blah, 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 lawsuit. We don't want lawsuit, and we don't want environmental damage. We want to build healing, more soil, healing. So always plan for your overflow route. Principle number 6, maximize living and organic ground cover with a living sponge. So yeah, like mulch is awesome. I love mulch. I love mulch so much, and living plants are better than mulch. The number 1 preferred food source of soil microorganisms are plant root exudates. The second most preferred food is dead organic matter. So if you are just starting out, mulch first. That's your only option, right? Because sometimes the environment is too harsh to even get things growing. But then once you've moderated that soil condition somewhat, as soon as you possibly can, get plants growing in there so that they take over this soil cover. And then that mulch is going to get digested. It's going to get eaten by those soil microorganisms, like the straw that the other question was about. You know, the straw kind of disappears is because the soil organisms have eaten it. And straw is a really easy, accessible food source. Wood chips are much denser. They take a lot longer to break down. Leaves, chopped up, whatever, prunings, et cetera, et cetera, et cetera. Like whatever you have, leave it on the ground. Do not rake up your organic matter and put it in bags and stick it out on the curb. Like keep it. Maybe it looks messy. Maybe it looks messy. Learn to love it. Just learn to love the messy look. Like we cannot expect our gardens to look like our kitchens or our living rooms. They are wild places, and the health of the planet is dependent on us embracing this new aesthetic. And, you know, if you must, like buy 10 yards of mulch from the landscape supply place and start there. You know, allow yourself a little period of adjustment before it's just full on chop and drop, right? If you need to, like there are ways that we can compromise in the beginning to get ourselves going, and so that we find ourselves in the ideal place eventually. But we can't judge each other. We can't judge our neighbors. We have to just accept each other all where we are. But we have to cover the ground. We have to cover the ground at the same time. So little caveat, the native bee people several years ago just let me know, hey, Lydia, 100% ground cover 100% of the time, you know, that kind of eliminates lots and lots of solitary ground dwelling bees who need bare soil. So leave a little bit of bare soil for your bees. There's lots of books you can look up and find out, exactly what aspect they like. You know, do they want an east facing little spot? You know, figure that out. Steward the bees, take care of the soil, cover as much as you can. Number 7, maximize beneficial relationships and efficiency by stacking functions so that you do more than just harvest water. So here the tree shading the tank, keeping it cool, shading the house, keeping it cool, providing food, providing habitat, root growth, encouraging microbes, soil porosity, water infiltration, et cetera, et cetera, et cetera. And number 8, continually reassess your system. The feedback loop, observe, repair, improve, practice balance maintenance. This is not something you set up and then walk away and expect it to stay the same. You can set it up and walk away and then you can have a jungle, or you can set it up and stay involved and then you can continue to have a place where, you know, there's open areas where you can hang out and enjoy and plant your little tender annuals. But it's a life producing, biomass producing process here that we're initiating, and things will grow and you will have to get in there. And, you know, there might be things that you take out that you put in that were the best thing there when the conditions were harsher. And now things have changed. And so you can take out and chop and drop those little things that started out that were the only things that could thrive in the beginning that are now kind of obsolete. And yeah, and then, oh, what is that? That's more organic matter. Yay, mulch, mulch, mulch. So follow all the principles together, celebrate abundance, invite your neighbors over, have people come help you install your swales, have people come help you eat the food that you grow on your swales, plant trees, plant natives, plant as many different things as you can, and just enjoy the process and feel this hope, feel this inspiration that we are not powerless. We do not have to wait for international summits full of governing people who don't agree with each other and really have money as their only priority. We don't have to wait for them to decide that we're going to burn less fossil fuel. There's no point. Who knows when that's going to happen? All they can agree on is that they'll come back in 2 years and talk about it again, like, oh, thanks. No, we can do this ourselves. You can start a community group. You can bring this to your kids' school. You can do this at your church. You can just do it by yourself and wait for your neighbors to come ask you what the heck is going on. This is effective. This works, and it's beautiful, and it'll reduce your water bill, and it will reduce your heating bill, and it will provide food for you and your family. So I hope that you just are like, hurry up and stop talking, Lydia. I got my shovel. I'm ready to go. All right. That's just a little replay there. Yeah. Okay. That's it. That is my slideshow. And I think there's just a couple of last minutes for a couple of last questions.
Yeah. Thank you so much, Lydia. We have, I'm just going to request that everybody takes a survey. So this lets the funders know that you appreciate these types of programs offered free of charge. And then also it guides to what other classes and topics you guys would like to, guides us to bring other topics to you. And then also, if you live in Solano County, there is a water efficient landscape rebate program. So if you want to do this, there's money for that. And so I'm going to put that link here too, so you can learn about that. Because like Lydia said, I encourage you all to start something small today. And if you commit, the doors will open. That just really resonated, you saying that, Lydia, because it is. You commit to this process, start small, just do something. And the land, you healing the land heals you, and then it recharges you to go out in this world and do all the tough stuff we have to do. So just, so let's get to one. I think here's the iPhone question. Let's load. iPhone? Oops, maybe they forgot.
Oh, hi.
Yeah, did you have a question?
Oh. Actually, I think I accidentally pressed the button, but
okay.
I really enjoyed the talk, Lydia. I love gardening, and I live in Northern California, where we have the rocky soil, and I don't know if you can hear me, but
Yeah.
thank you. I want to thank you for your session today. I look forward to your future.
You're welcome. It's a pleasure to be here. Yeah.
I'm ready to.
Oops.
I see somebody has a question about gray water. So, and yeah, and that's its own whole separate talk, but there is a nice section in here, rainwater harvesting for drylands. There's a bunch on gray water. And then Art Ludwig, check out Art Ludwig. He's from Santa Barbara, LUDWIG. And he has a publication called Create an Oasis with Gray Water. And he goes through, like, you know, the best sources, how to deal with, you know, whatever conditions. He has like a 80-page thing on his website about common mistakes, which is hysterical actually and so informative. So yeah, dive into gray water. You won't regret it. Well, and then, actually don't dive into it, but you know what I mean.
We also, and Gray Water Action's another organization that has a lot on gray water. We also had another question it says, in the video, the use of water runoff was amazing. Does it matter what type of roof you have? If it is a petroleum roof, what can you do with this water runoff?
So just super briefly, the stuff that I've read is that new wooden roofs have a flame retardant in them that leaches out for a while, but not, you know, after a couple of years. Like older wooden roofs are fine, wood shingle roofs. Those asphalt shingles also are leaching out initially, but then they kind of, you know, they've polluted everything they can, and now it's more or less clean. And you know, if you're collecting your roof water for your own personal drinking, then you need to be much more careful. But if you're just collecting the rainwater for the landscape, you really, like, it was coming down off the roof onto the landscape anyway, and soil microorganisms are the best option for breaking down those kinds of petroleum-based contaminants. The only thing they can't really handle is heavy metals, and some of them, like some of the fungi, actually can sequester heavy metals and take them out of circulation. So yeah, so go ahead and get your roof water onto the landscape. I heard there's a issue with mosquitoes. So for the most part, this water is not like a standing body of water for very long. I mean, you might have like a 12-hour period after a big storm where your swales are full while they're soaking in. If you are planning for your basins to actually double as ponds, like if you have a good clay soil and you can actually make them to be more or less impermeable, then you bring in a community of plants. You create a wetland community, which then would have the diversity of predators and things that would eat the mosquito larvae. So it's not an issue.
And then one last question, any book recommendation for native plants and food to grow in California?
Yeah, this one I really like, California Native Plants for the Garden. This one is published by East Bay Mud, and it's not just natives, but it's this kind of, you know, Mediterranean climate adapted plants. And then this one I inherited from Penny Livingston when she moved to the California Landscape Garden. I actually haven't read it, but I just grabbed it because it was with the others. And I find that the berms and swales are ideal for natives and some of our food plants. Obviously, if you have deer, gophers, food plants, they really need a lot of extra love. Like sometimes that's why we build little Alcatraz boxes for them. But depending on your situation, you can totally grow food on your berms, intermixed with your natives and your fruit trees. And sometimes that is a frustrating experience that will not work for you, but you know, it all depends.
Thank you guys all for being here. Lydia, thank you so much.
Nicole, this was so fun.
Yeah, and you guys all take good care of yourselves. Be radically kind in your thoughts and actions, and I don't know, go dig a swale, right? Get started.
Yay.